Alright, we are live again. We will get started here in a few minutes. Like always today, we are I'm starting early so that everybody can get logged in on time. Let me give it a couple more minutes. Excuse me. Alright, we're almost there. So we are in lesson 5, Harmonics. This will be in chapter 5 of your textbook. Alright. Well, it is right on time to start. Just going to give it probably till like 3:46. Then we'll get started. Okay, let's get started. Oh, okay. Excuse me. And a couple people join now, so. Alright, blank is the amount of harmonics on a line compared to the fundamental frequency of 60 hertz. Total harmonic distortion. This is a vocabulary term. If this is on the test, I would just look up total harmonic, like look up the answers and see which definition matches what you're looking for. Yeah, so the total harmonic distortion is a measurement of how much distortion there is. That's pretty simple. Blank sequence harmonics have the opposite phase sequence of the fundamental harmonics. So you can kind of the negative sequence. That's the opposite. That's what it's going just out of phase. Let me see if I have a picture. Let's see what we got for images. So here's a decent picture. I'm looking at the other. Oh, All About Circuits. That's a really good website. There's been a lot of stuff on All About Circuits. So the negative sequence is 180 degrees out of phase, and it creates this weird, or I guess a smaller wavelength. Blank is the ratio of the current harmonics to the maximum current load. Total demand distortion. Alright. A blank is a voltage or current at a frequency that is an integer multiple of the fundamental frequency. So that's what a harmonic is. So let's go back. Nope, let's go. So there was a good picture here. Let's zoom in. So, and this should be in your book. What I say? a minute ago. It is chapter 5 of your book. Should have some pictures just like this. So you've got, let's see, the red line is your fundamental frequency. So this will be your 60 hertz. But then electronics and various other things kick in these larger or smaller harmonics. So the third harmonic has 1.5 times the frequency. Or no, what? That's, oh, it's 3 times. Huh. The fifth harmonic, 1, 2, or 1, 2, 3, 4, 5. The fifth harmonic has 5. The seventh has 7. And when you combine all of the harmonics together, it creates this weird sine wave. And if you looked at an oscilloscope, yeah, the page 122 has some pictures like this. If you look at an oscilloscope with some electronics connected to a circuit, you can see that there is harmonic distortion. Why do we care? We care because power quality is what is affected. It's not everywhere that you'll try to fix power quality, but more and more as our society goes digital and has more electronics and computers, just all these different inductors and capacitors and chips and stuff, we will have more or worse and worse power quality. And mitigating that, you can mitigate it with various things, like there's special transformers you can put in that will mitigate it. Mitigating that will improve our quality of power. There's a reason why we've been using the neutral wire, like sharing the neutral less and less. You can have 2 circuits sharing a neutral and they should cancel out. But if you do not have a pure sine wave, they won't cancel out efficiently. So whenever everything was like fluorescent lights, not fluorescent lights, incandescent lights, the powers of those 2 incandescent lights would cancel out on the neutral, if they were on different phases. Now with LEDs aren't as bad as fluorescent lights, but fluorescent lights throw the power quality way out of whack. And there's actually more current on neutral than there should be. And if you were sharing the neutral between 2 circuits, you might have more current on the neutral than you do on either of the legs individually. Only single phase loads generate tripling harmonics. That is, if you are Fourier transform, harmonic filters. I went past the... Okay. I really passed it up. Nonlinear loads, power factor, I don't know. Total harmonic distortion, maybe I haven't passed it up. I don't know. Did I find it before? I have not. Only single phase loads generate tripling harmonics, and that has to do with distortion power factor. Let's see. Let me use the index. TRI transformer. probably under H for harmonics. Harmonics. Triplin. Page 101, 102, 116, 117. Probably 101 and 102. Triplin harmonics. Oh, that's the third, fifth, seventh, the odd multiples of the fundamental, or of the third harmonic. Oh, third, ninth, 15th. Okay. This is on page 101. There's a title, Triplin Harmonics, and you can read up about that. A switched mode power supply for electronic devices includes an internal control circuit that quickly switches the load current on and off in order to deliver a stable output voltage. That is one of the ways you can fight with harmonic distortion, is using a switched mode power supply. It delivers cleaner power. The blank is the peak value of a waveform divided by the RMS value. Current crest factor. Why do you need current crest factor? Current crest factor, current crest factor. Crest factor. I'm seeing crest factor on alright. Oh, there it is. For some reason, I didn't even look at this page. So it's how you can, it's an easy way to tell how much distortion there is in a waveform. That's what you would do to determine it. A high current crest factor can cause overheating of devices. As you can see by seeing me have to read up all this, it's not something, harmonics is not a thing that's discussed very much. This whole Transformers level 1 is a scientific, it's the theory of Transformers. It's not the actual hands-on get after it part of the Transformers. That will be in third year whenever you get to that. All your all the stuff in first and second year is theory, and I know that's frustrating, but that's what we have to play with. All right. Well, I will be putting up the last quiz here in a few minutes. I'm going to go ahead and get off of here. I'm just going to give these, we have a couple stragglers. I'm going to give them a couple minutes to finish. And I will see you guys at 5 o'clock.